Look closely around any large spiral galaxy, and you'll find a swarm of smaller companions, satellite galaxies, orbiting like moons around a planet. The Triangulum galaxy is no exception. Though smaller than Andromeda or the Milky Way, Triangulum hosts several such satellites, and their influence is far greater than their size suggests. These satellites don't just orbit quietly. They are active participants in the evolution of the main galaxy. One of the clearest signs of this are the tidal streams, long, ghostly trails of stars stretching out across space. These streams are the shredded remains of dwarf galaxies, torn apart by the gravitational forces of their larger host. It's a slow, majestic disassembly, a cosmic cannibalism that takes billions of years. As these smaller galaxies pass through the outer halo of Triangulum, they experience tidal disruption. Stars are stripped from their edges and flung into long arcs, while their dark matter cores, heavier and more resilient, may survive longer, orbiting deep within the galactic halo. These disrupted stars don't vanish. They become part of Triangulum's extended stellar halo, expanding its reach, enriching its chemistry, and preserving a fossil record of galactic history. By studying these streams, astronomers can trace back the interactions that built the galaxy. Each one tells a story of collision, merger, or gravitational entrapment. But satellites don't just lose stars, they change the galaxy they orbit. As they move through the halo, their gravity tugs on the larger galaxy's disk. These gravitational resonances can heat the disk, make it thicker, and even reorganize the spiral arms. In some cases, they trigger waves of star formation by disturbing gas clouds. It's like a child splashing in a pond. The ripples spread outward, reshaping the surface. Over time, multiple satellite interactions can create a flared disk, warp the spiral arms, and leave long-lasting marks on the galactic structure. Triangulum, though elegant, is not static. Its past is written in the scars of these interactions, and its future may include more mergers, more tidal streams, and perhaps the absorption of satellites entirely. But it's not all destruction. Satellite galaxies are also cradles of star formation. Many of them are rich in gas and form stars at a surprising rate. When they merge with Triangulum, they contribute not just stars, but fresh gas, the fuel for new stellar generations. This rejuvenates the main galaxy, keeping the cycle of starbirth alive. Some astronomers even propose that satellites act as timing mechanisms, delivering gas or inducing turbulence at the right moment to regulate the galaxy's growth. There's also a chemical story here. Satellite galaxies often have different metallicities, reflecting isolated evolution. When they merge or are stripped, they inject new chemical signatures into the halo, creating a layered history of enrichment. Like rings in a tree or strata in a canyon, these chemical layers help scientists date the major events in a galaxy's life. In essence, Triangulum is not a lone builder. It is a collaborative architect, assembling itself from a mosaic of past companions. Each satellite, whether consumed, distorted, or still intact, adds to the tapestry. Modern astronomy now recognizes these satellites not as minor curiosities, but as essential actors in galactic evolution. The Milky Way shows the same patterns. Sagittarius, the Magellanic Clouds, and others, all influencing the shape and activity of our galaxy. And so does Andromeda. It appears that no large galaxy is self-made. All are built, in part, by their cosmic communities. The study of satellite galaxies has blossomed with missions like Gaia, Hubble, and soon the Nancy Grace Roman Space Telescope. They help us see not only the positions of stars, but their motions, histories, and origins. In Triangulum, satellite remnants are beginning to be identified and mapped, piecing together a forensic reconstruction of its assembly. One day, we may have a complete family tree of Triangulum's past companions. a map of every dwarf galaxy it consumed, every stream it created, every flare it endured. Until then, each faint trace of stars beyond its disk is a whisper from the past, a reminder that even the smallest players can leave galactic-scale footprints, and that the universe is shaped not only by giants, but by the countless tiny forces that dance around them.